Let's bring this together now to look at the interannual variability of the annual cycle. Again, we are averaging over 5 north, 5 south, and looking at SST anomalies, zonal wind anomalies, and depth of the 20 degree isotherm or the thermocline. This is just looking at 96 to 2000. These are the very typical figures you will find every time there is a El Nino discussion of an event or a forecast and so on. If you look at NASA briefings on El Nino forecasts, which happens quite often, then you can find these kinds of figures where you're going from top to down. So you can see 96, which was having a slightly cold anomaly in the east and slightly warm anomaly in the west, has grown into a very strong El Nino here for 97-98 that we already saw in the Nino 3.4 time series. And then you can see that rather abruptly it switches to this very cold La Nina, and the corresponding warm anomalies happen on this side. Remember that strong trade winds, strong upwelling, colder SSTs pushing westward, and then the west getting warmer, so that's consistent. And this La Nina here persists for many years. So you have still the kind of annual cycle there. So you have coldest anomalies happening at the DJF time scale, and then the seasonal cycle reappearing, like the relaxation during the boreal spring months, and then again the DJF cooling. Sorry if I said warming, that's wrong. But interestingly, now here if you look at the zonal wind anomalies associated with the growth of this warming, there is a fairly strong extension of westerly wind anomalies, so positive zonal winds starting in the west during the early 97 December into March, and then extending eastward associated with this warming. So typically this is what I said. When you looked at the Walker cell, we looked at the convergence into the heating, but here there is westerly wind anomalies kind of pushing the warm waters westward. So there is a fast wave. We will see that there's a Kelvin wave that's going off into the east associated with the westerly wind anomalies, which is a downwelling Kelvin wave. Each wind burst can generate a Kelvin wave packet, so you can have multiple waves during a year, because it takes about 3 months for it to propagate from the west to east, and you can see it gets stronger. So this kind of strengthening of the westerly winds themselves with the warming makes it part of the system. So if you consider it as noise, then this would be what is considered a multiplicative noise. So it's part of the system that grows, perturbs the system, and then grows as the system responds to the noise itself. And the cooling and the conversion to the La Nina is associated not so much with the strong bursts like this, but easterly wind anomalies. And then there are higher frequency things happening here that are not large enough scale to change anything. Associated with this, the depth of the 20 degree C isotherm, it's near normal here, pretty much across. 96 was a mild La Nina, and you can see the perturbation in the thermocline is not great, but these westerly wind anomalies and the warming are associated with thermocline anomalies of almost 80 meters over here. That's fairly deep perturbation or deepening of the thermocline. So essentially we will see that the thermocline that is tilted in the climatological situation is going to flatten and get shallower because the warm water is going to get pushed out. In fact, I should have said that as well when we talked about the role of the ocean, that the wind anomalies that we saw in the Walker cell as well have a wind stress curl, and we know that when you have curl you're going to get sphere drift transport. So there is sphere drift transport out of the tropical box and into the tropical box, depending on whether the wind stress curl is lifting the thermocline and pushing water out, or it's pushing the thermocline down and bringing cold water in. Okay, so there is the evolution of the thermocline for the La Nina, which persists for multiple years. So just briefly, I won't get into the details. The persistence of the La Nina is considered to be related to these wind anomalies that can persist as well. You can see that these appear and disappear, where these are persisting for many years, which is related to the warming on the other side of the Indian Ocean, the monsoon forcing, and so on. But again, those are mostly explanations of what happens and not necessarily fundamental first principles. Okay, consistency theories, if you wish. Okay, so if you look at the vertical sections, the January 98 temperature and January 2000, you can see that the January 98 peak of the El Nino warming has spread all across. Thermocline has nearly flattened and shallowed. You can see the average depth here would be somewhere around 150, whereas here it's all flattened to about less than that. Okay, so January 2000, you are now getting into a strong La Nina, so the temperatures here have cooled down to 21, 22 degrees or so, compared to 27, 26, 27, 28 degrees here. So you can see the clear pulling up of the cold waters. And if you look at it as anomalies, delta T, then you can see that there are cold waters intruding from the west already before the El Nino is completely over. So you can see that the phase shift to the La Nina is already in place, and the warm waters have been spent, and the warm water pool is only remaining a little bit in the far east. And the change in the vertical, you can see again, this is for 2000, the coldest La Nina is coming to an end, so warm anomalies are coming across from the west, and the cold thermocline anomaly and temperature anomaly are still here. Okay, people argue about whether these are really anomalies or just movements of the thermocline versus these, which are actually sea surface temperature anomalies, which have consequences with the atmosphere, heat exchange, and so on. But without getting into that debate, you can see that it's the upper ocean that is involved in the interannual variability of the annual cycle. So we'll look at the large-scale signals of El Nino and La Nina in the next podcast, but you are beginning to get a sense of how this system is coupled and how it is related to the Walker cell in terms of the heat source and the movement of the heat source, and the ocean response and the coupled response. Okay, it will become clearer as we go forward and put in more details.